In this exercise, we consider a company which has two independent lines of business, and one of those lines of business handles heavy-tailed claims. What we are then going to show is that, in this case, fixed deductible reinsurance is preferable compared to proportional reinsurance. So let us just figure out what model we are working with and what the entire setup is. So this company has two lines of business. And let us just write up what line 1 of business is. So in their first line of business, they handle claims where the claims arrival process is counted by N1 and is a Poisson process with arrival rate 1/4. And the claim sizes are IID, exponentially distributed with parameter 1. And we assume that the claim size variables are independent of the claim number process. Okay, so what we note here is in the first line of business, we have light-tailed claims. Now this company also has another line of business independent of the first one, where the claims arrivals are counted by the process N2, which is also a Poisson process, which also has claims arrival rate 1/4. However, here in the second line of business, the claim sizes are IID, denoted by ZI, and are Pareto distributed with parameters 3 and 4, and 4 and 3. And according to the exercise text, what they mean by that is that the tail probability of these claim sizes is given by 3 divided by 3 plus x to the 4th. And what we note here is that these are heavy tail claims, and in particular sub-exponential. And as in the first line of business, also here we assume that the claim sizes are independent of the number of claims. And now we have one description for the first line of business and another description for the second line of business. And there is one more assumption to be made, because we assume that the two lines of business are independent. So we shall assume that the bundle YI NT1 is independent of ZI N2. Don't know what's the best way to write this. Let's just write it up as such. So we assume that everything that needs to be independent is independent. And now we are ready to write up what the total capital of this company is. The total capital capital is then given as C equal to, well, you have the initial capital plus the premiums, and according to the exercise text, the premium rate is 1. And then we have to subtract the claims. So from the first line of business, we count N1 claims, each of claim size Y1, Y2, and so on and so on. And from the second line of business, we count N2 claims, each of size Z1, Z2, etc., etc. And the thing here now is we would really like to establish some kind of model that we can recognize. And you see that we count the claim arrivals using Poisson processes. So some part of us kind of really want this to be a Cramer-Lundberg process, because in a Cramer-Lundberg process, you also count the claim arrivals using a Poisson process. However, the total claim size here is not written up as a compound Poisson process, so we're not yet sure whether CT is a Cramer-Lundberg process. If CT is a Cramer-Lundberg process, since we do not know whether the total claim size follows a compound, or since we do not know whether the total claim size is a compound Poisson process. So we're going to have to try and show that in A. And after A, we will establish that, in fact, indeed, the total capital can be considered to be a Cramer-Lundberg process. Okay, so see you in the next video, where we will show that the total claim size is a compound Poisson process, and we will also show what then is the claim arrival process and what the claim size distribution in that case will be.